Hi, welcome to this training course on electromagnetism and electricity fundamentals. If you are not familiar with this area, this video will explain or remind you the main phenomena. Enjoy your training course. Electricity is the phenomenon of electron circulation in a conductor. To produce this circulation, it is necessary to apply an electric potential on the terminals of a conductor. The difference of electric potential is expressed by volt unity. We can compare electric conduction with the flow of water in a pipe. The electric potential is like the pressure that induces the flow of water. The voltage potential gradient is at the origin of an electric field E. This electric field, like other force fields, is at the origin of an electrostatic force applied on charged particles. This force generates the motion of electrons. The movement of charged particles is the cause of a second physical phenomenon, the creation of a magnetic field. That means any conductor with current circulation creates a magnetic field. This is the case with windings used in electric machines. Like an electric field, a magnetic field is at the origin of magnetic forces. It is easy to observe these forces acting on iron, steel, and magnets. The materials attracted by magnetic field are ferromagnetic materials. Ferromagnetic materials seem to conduct magnetic field lines. To study magnetic phenomena, we must take into account two magnetic fields, H and B. H is the excitation magnetic field directly linked to the current circulation in a conductor. This field is proportional to the current circulation in the windings of a machine. B is the induction field that represents a concentration or density of magnetic lines. This concentration depends on the magnetic properties of the materials of the electric machine. This density is limited, and induction reaches a saturation zone if the magnetic field is too strong. The two vectors are linked together with a relation of proportionality. B is equal to mu multiplied by H and is equal to mu0 multiplied by mu r multiplied by H. Mu is the magnetic permeability of the material. Mu0 is the magnetic permeability of the air. And mu r is the relative magnetic permeability of the material. Ferromagnetic materials have a high relative magnetic permeability of above 1000. These two notions are really useful in determining the evolution of magnetic energy in a magnetic circuit. The magnetic energy is a product of the excitation magnetic field H and the induction field B. Energy is equal to half the product between B and H. The magnetic energy is essential to understand forces and torque acting in electric machines. The energy in the air is higher because the permeability is lower than in iron. Consequently, as systems want to minimize naturally their energy, the flow of magnetic lines in the air is reduced. Systems try always to find a state with a minimum energy. That is the origin of the forces and torque actuating in an electric machine. They move the mobile part of the machine, generally a rotor, to find the minimum state of energy. The last phenomenon is the induced voltage in windings when the magnetic field is evolving or changing over time. There is a magnetic flux variation in the coils of the windings of the machine. This variation of magnetic intensity produces an induced voltage. This induced voltage will create an induced current if the coil is connected to an external circuit. In that way, it is possible to create a voltage source and transform an electric machine in a generator. When the machine behaves like a motor, the induced voltage is opposed to the voltage supply. All these phenomena are very useful in understanding electric machine operation and basic electric circuits. Now you can follow the training courses about electric drives and their components. Thanks for watching.